Today what I want to do is I want to review a little bit what we did last class, and then I'm going to continue to cover new materials, including conservation of energy as well as comparison between kinetic energy and momentum. So first of all, I want to go over some of the most important things we covered last class. Especially I'm going to start from mechanical energy. Okay, hopefully you guys understand what work is. And for mechanical energy, we are going to talk about two kinds of energy. One is called potential energy, especially we focus on gravitational potential energy. And the second type is called kinetic energy. So potential energy is the potential to do work. You store some kind of energy and then you can do work. Just like, if you hold something very high and then it has potential, if you drop it, it has power when you hit something, right? Okay. So it's defined as mgh. So when something is elevated, and then we can calculate potential energy using this equation. So we talk about how important we understand how we find out the height, because we need to use a reference point to calculate the height. And like this case we talked about last class. So if you have the reference here, then the height is going to be 3 meters for both cases. Doesn't matter which way you move the object to 3 meters height. The second type of energy we talked about was kinetic energy. The kinetic energy is defined as 1/2 mass times v squared. Okay, both kinetic energy and potential energy, they are scalars. They have units of joules, which is very similar to work, but work is not energy. Work, energy, they are related. Work is a way to transfer energy, or you can change the energy. So the relationship of work and energy can be represented by work-energy theorem, which is net work equals changing kinetic energy. Okay, so here I want to use this as an example to show you the work-energy theorem application. So assuming friction is the same, a car moving at 50 kilometers per hour skids 15 meters with locked brakes. How far will the car skid with locked brakes at 150 kilometers per hour? So this question has two different scenarios. The first scenario, the car, they have a lot of common things, there's only friction, the same car, okay? But first case, the car is moving at 50 meters per hour. The second case, the car is moving at 150 kilometers per hour. So we want to find out, the first car is going to skid actually 15 meters. We want to find out how far the car is going to skid for the second scenario. So for this is a very typical application for work-energy theorem, since there's only friction horizontally, which is doing work on the object. So we can use net work equals changing kinetic energy here, and changing kinetic energy is final kinetic energy minus initial kinetic energy. So net work, because friction is the only force which does negative work here, because friction is this direction, the distance is this direction, they're in opposite directions. That's why work is negative. So then we have final kinetic energy, which is 0, because it's going to, the brake is going to stop the car eventually, minus initial kinetic energy. So based on that, we can have negative Fd equals negative 1/2 mv squared. So eventually we have Fd equals 1/2 mv squared. So this is the starting point. We are going to solve this problem. But how can we go from here? Okay, since this question has two different scenarios, in physics, if we are dealing with two different scenarios, the common method we can use ratio to compare two different scenarios. So we start from Fd equals 1/2 mv squared. So the first case, because friction is the same, but the distance is different, so I use subscript 1 to represent it. The second case is subscript 2. So then what I do is I do the ratio, okay, of these two equations. So what I can do is Fd2 divided by Fd1 equals 1/2 mv2 squared divided by 1/2 mv1 squared. Okay, Then you can cancel these common things. What we have now is d2 over d1 equals v2 squared divided by v1 squared. And this can be represented by this case mathematically. Now, if you look at these two, we are looking for d2. We know d1 is 15, okay? We're looking for d2. So I'm going to put this up here again. So d2 divided by d1 is v2, v1 squared. So as you can see now, we're ready to solve the problem. Okay, v2 is 150. This is 50 squared. So we have 3 squared, which is 9. Okay, so in this case, we know d2 is 9 times d1. Okay, d1 is 15 meters. So we have 135 meters for d2. So the second car is going to skid 135 meters for the distance. Okay, so this example shows you how we can apply work energy theorem to solve problems. Okay, so that's the first part of this today's class. So the second part of today's class I want to talk about is going to be conservation of energy, and I'm going to do another video